Hello everybody, this is Naveen Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. So in the last few classes we discussed about the Fourier transform. So in today's class we will discuss about Fourier cosine transform as well as Fourier sine transform. So what is Fourier cosine transform and what is Fourier sine transform mathematically? The infinite Fourier cosine transform is defined as is defined as fc of u is equal to integral between 0 to infinity f of x into cos ux with respect to x. So this is the mathematical representation of the Fourier cosine transform here. Okay, it is Fourier cosine transform. And the inverse Fourier cosine transform is defined as f of x is equal to, it is 2 by pi integral between 0 to infinity fc of u into cos ux with respect to u. In a similar fashion, we can define what is the Fourier sine transform as well as its inverse transform. And as we know that fc of u is representing the Fourier cosine transform. In a similar fashion, Fourier sine transform is denoted by fs of u, and it is defined as the integral between 0 to infinity f of x into sine ux with respect to x, and its inverse transform, that is inverse Fourier sine transform, is denoted by f of x is equal to, it is 2 by pi integral between 0 to infinity, and inside the function will be fs of u into sine of ux with respect to u. So these are the four formulas represents a mathematical form of Fourier cosine transform and its respective inverse Fourier cosine transform, as well as fs of u is representing a Fourier sine transform and this f of x is representing the respective inverse Fourier sine transform. So next we will solve some problems on this Fourier sine transform as well as Fourier cosine transform. So we will solve a problem on Fourier sine transform as well as cosine transform. Just we saw the formulas related to cosine as well as sine transforms. So now by using those formulas we are going to find the Fourier cosine and sine transform. So let us take this problem. Find the Fourier cosine and sine transform of e raised to minus ax. So here the function f of x is given and we need to find out both fc of u as well as fs of u. Fc of u is representing a cosine transform and fs of u is representing a sine transform. So let us take a cosine transform, that is fc of u is equal to integral between 0 to infinity f of x into cos of ux with respect to x. So first we find the cosine transform, later for the same function we will find a sine transform here. Since we know that f of x given, so that is nothing but f of x is equal to e raised to minus ax. So substituting this f of x in the cosine transform, so we have e raised to minus ax into cos ux with respect to x. Now we need to evaluate this function, the product of two function between the integral 0 to infinity. And since we know that e raised to minus ax into cos ax is already in the standard form, we have a formula here: integration of e raised to ax into cos bx with respect to x can be written as e raised to ax divided by a square plus b square into a into cos bx plus b into sine of bx. So this is the integral of the product of e raised to ax into, it is cos of bx. So the same formula we apply here. So when you compare this integral with this standard form, we come to know that in place of a we are having minus a, and in place of b we are having u. So in this formula, in place of a you need to replace minus a, and in place of b you need to replace u. Therefore the integral becomes here e raised to minus ax divided by a square plus u square into bracket, a is nothing but here it is minus a into cos of ux plus b is nothing but u into sin bx, that is sine of ux, and applying the limits between 0 to infinity. So simplifying further, so it is fc of u. So applying the upper limit infinity. So in place of x, wherever x is there, you need to substitute infinity. So when you substitute the upper limit infinity in place of x, you are going to have e raised to minus infinity. So e raised to minus infinity will be definitely 0. So 0 into any function will become 0. And later we need to apply the lower limit, that is 0. And since we know that while applying the lower limit we need to take a minus sign, so therefore e raised to 0 become here 1. So it is 1 divided by a square plus u square into bracket. Obviously here we need to take a minus sign because we are applying the lower limit. And now substituting x equal to 0, we have cos 0. Cos 0 is nothing but 1, so remaining is minus a here. And since we know that sin 0 will be 0, therefore this term vanishes. So therefore we have the final answer a divided by a square plus u square, and this is representing a cosine transform of a given function f of x equal to e raised to minus ax. So this is the first part. Okay, we got a cosine transform of the function f of x. Now we will find out the sine transform of the given function e raised to minus ax. So and we have a formula for the sine transform. The sine transform of a given function is defined mathematically as integral between 0 to infinity f of x into sine of ux with respect to x. Once again replacing or substituting f of x and evaluating between the limits 0 to infinity. So we have 0 to infinity here, and we know that f of x is nothing but e raised to minus ax into sine of ux with respect to x. Now we need to evaluate this integral. Obviously e raised to minus ax into sine ux is in the standard form, and we can easily evaluate it by using a standard formula, that is integral of e raised to ax into sine of bx with respect to x is nothing but e raised to ax divided by a square plus b square into bracket a into sine of bx minus b into cos of bx. So this is the answer of the standard integral e raised to ax into sine of bx. The same formula we are going to apply here, but in place of a we need to replace minus a, and in place of b we need to replace plus u. Therefore, replacing a as minus a and b as u, this integral becomes e raised to minus ax divided by a square plus u square into bracket a is nothing but minus a in this problem and sine of ux minus b is nothing but here it is u into cos of ux, applying the limits between 0 to infinity. So once again applying the upper limit is infinity here. So e raised to minus infinity will be 0. So 0 into anything becomes 0. Therefore, for the upper limit, complete function becomes 0. Now applying the lower limit is 0, and while applying the lower limit we need to take a minus sign. So it become minus first, we'll put a minus sign, then e raised to 0 will be 1 divided by a square plus u square here. Inside the bracket sine 0 will be 0, so 0 into anything will be 0, and cos 0 will be 1, and since we are having a minus u, so here we have minus u, and the final answer will be u divided by a square plus u square. So this is a sine transform of the given function f of x, and hence the solution. Let us take the next problem. Find the Fourier cosine transform of e raised to minus ax divided by x. So again the same Fourier cosine transform we need to find, therefore we make use of the cosine transform formula. So fc of u is equal to integral between 0 to infinity f of x into cos ux with respect to x. Replacing f of x as the given function, since given that f of x is equal to e raised to minus ax divided by x. So replacing f of x as e raised to minus ax divided by x into cos ux with respect to x. Since the given integral is not in the standard form, so therefore first we need to reduce this integral into the standard form, then we can evaluate the integral. But how can we reduce this integral into the standard form? Definitely we make use of the Leibniz rule. What is the Leibniz rule? Leibniz rule is one where we differentiate the function under the integral sign, so that we can reduce the integral into the standard form. But here while differentiating under the integral sign, we cannot differentiate with respect to x, so we need to differentiate it with respect to other than x, that is here u is the parameter, so we are going to differentiate under the integral sign with respect to u. Therefore we have here dfc by du is equal to 0 to infinity e raised to minus ax divided by x, and the derivative of cos ux will be minus sin ux into x with respect to x here. And since this x and this x get cancelled, and we have dfc by du is equal to integral between 0 to infinity, and I will take minus sign outside. Remaining is e raised to minus ax into sine of ux with respect to x here. And since now the integral is reduced into the standard form, we have a formula here again, so we used it in the previous problems. E raised to ax into sine bx with respect to x is equal to a into, it is e raised to ax divided by a square plus b square into bracket a into sine of bx minus b into cos of bx. So this is the formula for the integral of e raised to ax into sine bx, and here in place of a we are having minus a, and in place of b we are having u. So replacing according with the formula, so we have minus, it become e raised to minus ax divided by a square plus u square into bracket minus a into sine of ux minus u into cos of ux, applying the limits between 0 to infinity. So for this, now applying the upper limit as well as lower limit. Since the upper limit is infinity, therefore e raised to minus infinity becomes 0. 0 into anything will be 0. So coming to the lower limit, so there is a 0, and since there is a minus sign, and we know that every time while applying the lower limit we need to take a minus sign, so minus into minus become plus here, and therefore e raised to 0 will be 1 divided by a square plus u square into bracket sine 0 will be 0, therefore this term becomes 0, and cos 0 will be 1, so remaining is minus u here. Therefore finally we have the answer minus u divided by a square plus u square. So this is dfc by du. It is a derivative of fc, but what we need only fc. Therefore in the middle of this problem we differentiated. Now definitely we need to integrate it to get fc. Therefore here I will write dfc by du is equal to minus u divided by a square plus u square. Now separating the variables, so it is dfc equal to minus u by a square plus u square du. Now integrating both side, so we get fc is equal to, okay, integrating both side, so the integration of dfc is nothing but fc, and the integration of minus u divided by a square plus u square is, it is 1 by 2 times of log of a square plus u square plus some constant c. Definitely there is a minus sign, so it will be minus of, and hence this is the final answer for the given function, that is e raised to minus x ax divided by x, hence the solution.